Alright, so for this particular lesson, you will learn how to identify the different elements of a given node in a network diagram. You'll be able to perform the forward and the backward calculation. This is essential because the forward and the backward will reveal to us several important information, such as the durations of the project. It will reveal us what is the earliest day, start date, or the finish date, or what is the latest start date or the latest finish date of a given activity. In addition, you will learn also the different types of float time. Okay, so you'll be able to differentiate total float and the free float, and it allows you to calculate the value of the free float and the total float within a given network diagram. And also within the network diagram, it allows you to identify the critical path by knowing those critical activities within a given path. Alright, so again, for this lesson, I already provide you a little bit of the background of the activity duration and network calculations. The duration in the previous topics as part of the planning stage, scheduling is one of those tools that allows us to create the plan for the project. And for us to be able to prepare the schedule, it is essential for you to determine the durations of a given activities. So again, for you to be able to prepare the schedule, of course, you need to know first the different types of activities that comes with the project. That's why you've learned about the WBS, the work breakdown structure that allows you to break the project into a manageable tasks or activities. And then the second step is to determine the duration in each of these given activities. In the previous lesson, you've learned about the time, which is equal to the quantity divided by the productivity rate, or a quantity multiplied by the productivity rate, depending again on the unit of the productivity rate. And then later on, I'm going to show you how to perform the forward and the backward calculations, and then how do you identify those activities that are in a given critical path. Alright, so what are those that you are going to consider for scheduling? Of course, the things are the activities that included in a given project. The second thing is the durations, that how long will it last, or how long will it take to finish a particular task. The third one is the sequencing of a given activities. Which activity needs to come first, which activity that goes next, and which activities that can be done at the same time. And then the fourth one will be to perform now the forward and the backward calculations. Alright, and by the way, for this particular lessons, you have the supplementary documents for you to be able to follow those calculations, because in that document I provided the illustrative examples in which it allows you to follow it in a step-by-step procedures. Alright, so for you to perform the when you perform the forward and the backward calculations, there are key elements that you will be able to calculate that will aid the project managers as they monitor the status of a given project. And those are the early start, that is a particular event in which the earliest possible way that you will be able to start a given activity. The same thing also with the early finish, the earliest possible early time that you will be able to finish a given activity. And if ever there is an available float time, what is that latest time that you will be able to finish or start a given activity. And then of course the last element is the float time. So what is a float time? A float time, it is an amount of time that you can use to delay a particular activity, either without impacting the duration of the entire project or without impacting any succeeding activities. So later on, I'm going to explain to you those two different types of float time. Alright, so as we begin with the calculation of the network diagram, there are several conventions that we need to follow. We are going to make use of this particular convention here that I provided you. We have here on the upper left of the box, that will be the early start of a given activity. This is early finish, that is the EF. Inside the box, you will find the activity. You have the duration. We have the total float, the free float. We have the latest start, and we have the late finish. So that will be the convention that we are going to use as we move on and as we draw the network diagram. And again, in the previous lesson, you've learned how to draw the network diagram. When you draw the network diagram, there are several things you need to keep in mind. You need to draw the network diagram from left to right, top to bottom, in a sequence in alphabetical, okay, from left to right, top to bottom. Anyway, I'm going to show it to you as we move on into the calculations. Alright, so how do we calculate for the forward pass? So to calculate that, to determine the early finish, we just need to add the early start of the activity in question plus the duration of the given activity. Then you have to proceed to the next node. The early start is equal to the early finish of the preceding. That means that is the activity that comes before that particular activity in question. Alright, so if multiple predecessors carry the largest numbers, I want you to keep that in mind as you move from left to right in your calculation. Carry over whichever is the largest numbers in your calculations, and then continue on up to the last activity. Now for the backward pass, you can only perform the backward pass after you have completed the forward pass. You don't calculate those at the same time. You need to calculate it one at a time, moving forward and then going backward for your calculations. And I'm going to show you how you're going to calculate them later on. Alright, so for the float calculations, there are two types of float time. We have the total float and we have the free float. So what's the difference between these two? The total float, or the TF, that is the amount of time that you could delay a given activity without impacting the overall duration of the entire project. So take note of that. Total float without impacting the duration for the entire project. The free float, it is the amount of time that you could delay a given activity without impacting the duration of the succeeding activity. So the total float, entire project, free float without impacting any succeeding activity. So the total float is calculated as a difference between the late start minus the early start, or the late finish minus the early finish. Either of those two. And the free float, whichever is the minimum of the early start of the succeeding activity or activities, because there might be several numbers of succeeding activities. You need to consider the minimum of the early start of those minus the early finish of the activity in questions, or the activity that you are determining the free float. Anyway, I'm going to show you that and clarify it as we move on to the problems. Alright, so let's take a look at this one here. We're asked to draw the logic network and perform the CPM calculation of the scale shown. Alright, so with this given table here, IPA correspond to the immediate preceding activity, okay? And you will notice here that activity A has no preceding activity. Activity will follow your activity A, C will follow your activity A, and D will follow your B, and your E will follow your B and C. What does it mean is that you cannot proceed with your activity E unless both of those two activities are completed. The same thing also with your activity G. All your D, E, F must be completed first before you move on to your activity G. Alright, so this is how you're going to draw them. Okay, so we have here your activity A. It has no predecessor. Your activity and activity C will follow your activity A. As I mentioned a while ago, drawing the network diagram will proceed from left to right, top to bottom, in their alphabetical orders. Okay. One thing that you need to avoid, if you need to avoid, okay, as much as possible, there must be no intersection or crossing of the network arrows. There will be cases, especially if there will be a lot of activities involved, that you cannot avoid intersection of those. One thing that we usually do is to create a jump line. I don't know if I have that in our succeeding examples that we have. Alright, so you have, first thing you have to do here is to draw the network diagram. Okay, by looking at the table, you will notice here that your activity E need to follow both your activity B and your C. Your activity D will follow only your B, and your activity F will follow only your C. And then we have the last activity, which will follow all your previous activity D, E, and F. Alright, so with the calculation, you have to begin with 0. Well, this is what we call, for manual calculation, we usually use the end of day convention, as they call it. Although we start here at 0, which means that that particular activity will begin the next day, which is 1. The reason why we begin with 0 in manual calculation, it's easy to do the mathematical calculation, because you have here 0 plus 5, that is the duration, is equal to the early finish of the activity. Now, if you're going to begin with 1 here, and you do your math calculations of 1 plus 5, what will happen is that you will end up on the 6th day. So if you're going to count 1, 2, 3, 4, 5, and 6, that will give you a 6-day duration, and that may confuse you because it says here the duration of your activity A should be only 5. And that's the reason why in manual calculation they make use of what they call the end of day convention to make the adding and subtracting of numbers easy. But as a project manager, it is understood that in this particular case, it is the end of day convention, which means this will begin on the first day and this one ends on the end of the day. Okay, so for that particular case. Alright, so let's begin. So we have here the start is 0. The early finish is equal to the early start plus the duration. So we have here 0 plus 5 is equal to your 5 here. And again, the early start of succeeding activities is equal to the early finish of the previous activity. The maximum of the early finish of the previous activities. So what did I say maximum? Because there will be cases wherein a given activity is coming from or preceded by 2 or more activities. And I'm going to show you that as we move on to your activity E. Alright, so 5 plus 8, that will give you 13. And then here your C is preceded by activity A. The early start of activity C is equal to the early finish of the previous activity. So we have here 5 plus 6 is equal to 11. Alright, so for your activity D, it is only preceded by your activity B. So we're going to use the early finish of your activity B, which is 13. So you're going to bring it here 13. 13 plus 9, and that will give you 22. Now you will notice here that your activity E is preceded by activity B and C. You must be asking which one of those two that we are going to consider. You need to remember, as one of the rules, as you perform the forward calculation, carry over the largest or the maximum of the previous activities. So in this case here, we have here 13 and you have 11. So the maximum here is 13, and that's the one that you're going to carry over for the early start of activity E. So 13 plus 6, and that will give you 19. Move on to your F. It is preceded by activity C. So you just need to carry over the early finish of the previous activity, okay, because your F is only coming from your C. It's only one. Unlike your E, it is coming from two different activities. And again, you can only solve the forward and the backward one at a time. You need to complete first the forward before you move on into the bottom part, which is the backward calculations. Alright, so let's move on to your activity G. G is preceded by activity D, your E, and F. Because we have three preceding activities, we have to carry over whichever that give us the largest or the maximum of those three preceding activities for the early finish. So we have here 22, 19, and 14. So we are going to carry over whichever is the maximum. So the maximum here is 22. That's why we brought it here 22. So 22 plus 1, that will give you 23. And then whatever, again, once you finish the forward calculation in a given network, whatever that early finish that you have on your given calculation, that tells you the durations of the project. So again, as you finish performing the forward calculation, you should be able to determine now the durations of that particular project. So for this particular case, the duration of the project is 23 days. So to perform the backward calculation, carry over this one here to the bottom. That's why we have here 23. Always, okay? So whatever the early finish, that must be also equal to the late finish. So we're going to move backward now from right up to left after your activity A. Alright, so we have here now, if on the forward we did addition, as we perform backward, we are going to subtract the duration. So in this case here, to determine the late start, we have here 23 minus the duration, that gives you 22. And your activity D is coming from your G, so you have to carry over your 22. The same thing also with your E. You're going to bring this one here 22, this one to your F, which is also 22. Alright, so 22 minus 9 gives you 13. 22 minus 6 is equal to 16. 22 minus 3, that is 19. Alright, so we're done D, E, F, and your G. Let's move on to your B. Notice here that we have two arrows, which means they are connected by two succeeding activities. Remember, when we did the forward calculation, we considered the maximum as we move forward. This time, as we perform the backward, you have to consider the minimum. Alright, so for your B, you're coming from your D and your E. Notice here we have 13 and we have here 16. So how do I know that we are choosing between your D and E? Notice this arrow here. They are connected both to your B. So there must be two choices on the value that you're going to carry over. So remember, we're doing backward. Consider the minimum value. So what's the minimum value between these two, 13 and 16? That is 13. So we carry over that. So we have here 13. Take a look at your C as well. C is connected by two given line. Okay, so we are going to choose between the late start of your F and late start of your E. Whichever is the minimum between the two, that's a value that you're going to carry over backward. So in this case, the minimum between 16 and 19 is 16. That's why you carry over here your 16. 16 minus 6, that will give you 10. Alright, so as you move on to your A, It is connected by two arrows, this one here and this. So we need to choose between 5 and your 10. So whichever is the minimum between the two, that will be the value that you're going to carry over. So in this case, 5 is the minimum. 5 minus 5 equal to 0. Alright, so there are several rules here when you do your network calculation. The first one, as you perform the forward calculation, for you to determine the early start of a given activity, you need to consider the maximum. As you perform the backward calculation, you are going to consider whichever is the minimum, okay? To determine the late finish of a given activity, you have to consider whichever is the minimum of the late start of the succeeding activities. The third thing that you need to keep in mind is how do you determine which activities that has a critical path. Take note of this. In any given network diagram, you must always have at least one critical path. If you don't have any critical path in your calculation, you mess up. You may need to go back and redo your mathematical calculations, because in a given network diagram, there must be always one critical path. Alright, so the next thing that you need to keep in mind is that, so how do we know which of those activities are critical? One thing that I want you to notice that in a given activity, if both the numbers at the top and at the bottom are the same, then that is a critical activity. So take a look at the diagram. Activity A has both the top and the bottom are the same. That means activity A is critical. Activity C, they don't have the same numbers at the top and the bottom. That is not a critical activity. Activity B, they have both the same numbers at the top and at the bottom, which means that activity B is a critical activity. Then activity D, they have the same numbers at the top and at the bottom. That means D is a critical activity. The rest, E and F, they don't have the same numbers at the top and the bottom. That means that is E is not a critical activity. The same thing also with your F. So for your G, of course, that is the beginning last activity that should be given a critical. So again, in a given network diagram, there must always be critical. Okay? And how will you determine if an activity is critical? Both the top numbers and the bottom numbers are the same. So in this case, your A, B, D, and G are the critical path. So I want you to take note of this. Critical path are the connections of activities from beginning to end. Critical activities, those are the activities that has the same numbers at the top and at the bottom. And these activities that are in the critical path, those are the activities that you need to put focus as a project manager, that you cannot afford to delay any one of those. Because if you are going to delay any one of those activities within a critical path, it can create an impact to the overall duration of the project. This guides you as a project manager. Why is this very important? For most projects, there is always a clause in the contract that if you will not be able to complete the project in the agreed duration, you are subjected to a given penalty. And what is that penalty that we call in the construction industry? We call it DLD, or liquidated damages. And that is one thing that we don't want at the end, because that may drain the profit, or it may drain the cash of your company. Okay, so again, as a project manager, those are things that you need to watch out. Okay, one thing that I want you to keep in mind again is that as you complete the forward calculation, the end number that actually gives you the duration of the project. Alright, so once you've done that, what you need to do now is just plug in into your table your early start, early finish, late start, late finish. You just need to copy that from that network diagram. The next thing that you have to calculate now is your TF and your FF. So how do we calculate that? Alright, for you to be able to calculate the TF and the FF, you need to use your network diagram. Alright, first, for every activities that are within the critical path, the TF and the FF are zeros. Again, the TF and the FF are zero for all those activities that are in the critical path. That means that your activity A, activity B, activity D, and G have a zero TF and FF. Take a look at the table. So here, your activity A, C, G, I, and N are all, oh, that's problem number 2. Where is our problem? Okay, it didn't ask us to calculate the, on the problem, you're just asked to draw the logic network and the critical path. But anyway, as we move on to problem number 2, that's how you are going to calculate them. So again, there are several rules here. The TF and the free float of any given activities that are in the critical path, those are all zeros. Alright, why is that? Because TF is the difference between the late start minus the early start, or the late finish minus the early finish. So that is a TF. Okay, and I'm going to explain to you the free float as we move on to the second problem. Okay, all right. So let me show you that on the second problem here.